In this video, we will be dealing with WAEC November 2011. Part B, the essay section. Precisely the West African Senior School Certificate Exam, Chemistry, Paper 2. Here, question 3 and 4. But before we continue, I want to thank those of you who have taken your time to subscribe to this channel. And for those of you who haven't subscribed to this channel, please like this video, share to other learners, and take some time and subscribe to this channel so that subsequent papers that we are going to be discussing will come directly to you. Then, for those of you who are facing difficulty in solving some problems, WAEC problems, questions in solving questions in chemistry in WAEC, remember that our goal is to ensure that you have good grades in your WAEC examination. So channel to us the different questions that you are finding difficulty in solving them, and we will get back to you. Thank you very much for taking your time to subscribe to our channel. Let's get started. We will be starting with question number 4. Question number 4. Question number 4. A1. What is meant by saponification? 2. List the raw materials needed for the manufacture of soap. 3. Name the main byproduct obtained from the manufacture of soap. Well, that is just 5 marks for this the 1, 2, and 3, 5 marks. So, your much material is not really needed. Much material is not really needed. But I have written, for the purpose of revision, I have written to you because I have written lengthily so that most of you can better understand. But during the exam, much work is not needed. So 5 marks. So precisely, what is saponification? You should know that saponification is a process that involves the conversion of fat, oil, or lipids into soap and alcohol by the action of a strong aqueous alkali. Again, I said saponification is a process that involves the conversion of fat, oil, or lipids into soap and alcohol by the action of a strong aqueous alkali. Soap are salts or fatty acids, which in turn are carboxylic acid with long carbon chain. In other words, I am saying that for the purpose of revision. In other words, I am saying that what is needed is you may have fats, you can use oil, or you can use lipids. And when you use all this, when you use fats or oil or lipids, then you can, what you do is you can now react with the alkali. Now what is being produced is alcohol and soap. Okay, I just want to break this down so that you can better understand. so you can better understand. Okay, for instance, let me have this. Okay, remember that when you have the fats we are talking of, chemically we call it triglyceride. Triglyceride, fats or oil. These are what we call triglyceride. And they are formed as a result of what? They are formed as a result of the acid reacting with the alcohol. So, for instance, how is triglyceride formed? This is the production of triglyceride. See, when you take alcohol, in this case, there is a glycerol. Glycerol are something like it's a triol. That is with three OH group attached to the carbon chain. Then with fatty acids. Here you have R1, R2, R3. All these R1, R2, R3, they are representing what we call the alkyl groups. They are representing alkyl group depending on the fatty acid you are using. So that way we are saying that this R1 is an alkyl group, this one is here another alkyl group, and this one is here another alkyl group attached to the acid group, the carboxylic acid group, which is the COOH. Now, this glycerol, when they react with the fatty acids, when this glycerol react with a fatty acid, what happens? A molecule of water, in each case, the OH from the acid and the OH from the alcohol, hydrogen from the alcohol, and OH from the acid will drop down and give you a molecule of water. So there are three OH from the hydrogen from the glycerol, and there are three OH from the fatty acid. We will have three molecules of water that will be produced. And that will result in what we call, because when an acid reacts with an alcohol, your basic knowledge of organic chemistry, when an acid is reacting with an alcohol, what is usually observed is an ester. The carboxylic acid and alcohol reacting, we call it an ester. So there are three esters group. So this first one forms an ester, and this second one forms an ester, and this third one forms an ester. All are linked by this carbon chain here. So this is the first ester, this is the second ester, this is the third ester. We call them, there are three ester group molecules. And the chemical name given there is a triglyceride. And there are three molecules of water that are released as a result of this bonding here. So this triglyceride is the one we are going to react with. Is the triglyceride that we are going to react with a very strong alkali. This is it here. Is this triglyceride that we are going to react with a very strong alkali. So in the production of soap, you may either use the fatty acid, you may use oil, you may use the fatty acid, you may use the oil, or you may use lipids. Some places with fats from animal, when they are slaughtering animals, they remove the fat and go and melt it and process it in the production of some quality type of soup. Where we don't have oil, where we have vegetable oil, we can use it and still do it. Where we have oil from nuts, like palm nuts or kernel oil, we can use it. So we can use the different types of oil, fats, or lipids in the production. But the first procedure is the production of a triglyceride, where we will have glycerol reacting with fatty acids to form what we call a triglyceride. That is 3 ester group molecules and 3 molecules of water that are being released. The triglyceride is now the reactive agent now that is going to be used in the production of soap. That triglyceride will now react with a strong alkali. It could be potassium hydroxide or sodium hydroxide. So now this is the first stage in the production of triglyceride. The second stage in the production of soap now is the 3 esters molecule plus the alkali will give us the alcohol plus the soap. Now, this is the triglyceride that we got the other time. This is the triglyceride that we got the other time. Now, we now react with a strong alkali like sodium hydroxide. Remember, I told you the triglyceride could be from fat or from oil. We now react with a strong alkali, that is sodium hydroxide. What happens is that during this reaction, the mechanism there is that there's going to be breakage of this bond. This ester linkage bond is going to be broken. The ester linkage bond is going to be broken. It's going to be broken down again. The first ester linkage bond, this bond that was formed here, the bond that was formed as a result of the hydrogen from the alcohol and the OH from the acid, carboxylic acid, to give us the triglyceride, is going to be broken back again. So now, when it is reacting with an alkali, the bond is going to be broken down again into the very alcohol again. That is the glycerol into the glycerol again. Now, instead of the fatty acid, what happens? Instead of a fatty acid, we will form a fatty acid salt. Why do I say that it's a fatty acid salt that is going to be formed? It's because the sodium, the alkali, if we are using sodium hydroxide, the metal that is the metal that is the sodium from the sodium hydroxide is going to attach itself to the carboxylic acid because hydrogen has been taken off. So when this bond is broken here, sodium here comes and attach itself here. Sodium and oxygen will come and attach itself here to give us what we call the fatty acid salt. Then the one hydrogen of the sodium hydroxide, the other one hydrogen is the one that will bring back the glycerol from the colors. You will see it there, the green. The one will break and attach itself here. So precisely, formation of salt, what we call saponification, when this triglyceride react with a strong alkali, glycerol is formed and a fatty acid salt. The triglyceride once more is a fatty acid or the oil. The alkali is the sodium hydroxide in this case. Then this glycerol we are talking of, there are 3 OH group. That's why we are talking that is an alcohol. There are 3 OH group. OH group belong to the group of the homologous series of alcohol. In that case, we can name it as propan 1,2,3 triol because there are 3. If we were to use the IUPAC system of naming, we will say propan 1,2,3 triol. That's the glycerol plus the fatty acid salt, which we call it the soap. So there are going to be 3 soap molecules here. Then, if you want to know how these soap molecules can be represented, if you want to know how this soap molecule can be represented, this structure of this soap molecule here, this is how it can be represented. Here, as I told you, this arrow here represents an alkyl group. It represents an alkyl group. So we have the COO Na. The COO Na will remain. Then the alkyl group here could be CH, then CH2, CH2. This N shows that the CH2 can go to about 1,000. It could go to about hundreds. The number is a polymer. But the major identification there is the salt, the COO-Na ion, COO minus Na plus, indicating that it is a salt of fatty acid. So this is the structure of the soap. So now we want to go back to our question. Our question says, what do you understand by saponification? As I told you, saponification saponification is a process that involves the conversion of fat, oil, or lipids into soap and alcohol by the action of a strong aqueous alkali. Soap are salts of fatty acids, which I just showed it to you, which in turn are carboxylic acid with long carbon chain. So if you can write this, because no much is needed, that is just about 2 marks. No much is needed. They just write this definition there and write the equation. You have your marks. The duties I was given here is for the purpose of revision. Let's go to question number 2. That is the second part of it. The second part of it lists the raw materials needed for the manufacture of soap. The raw materials that are needed for the manufacture of soap. The raw materials that are really needed for the manufacture of soap, at least I have just listed them there. The raw materials that are needed for the manufacture of soap. You will see that the raw material, as I just mentioned, we will have fats. That is called the fat. That is fatty acids. Fat, or what we call fatty acids, or vegetable fats. The vegetable fats are what we call the olive oil, palm kernel oil, coconut oil. Those are the different fatty acids or vegetable oil. So if you say fatty acid or vegetable oil, you can list those ones. The second one is there must be a strong inorganic alkali, such as sodium hydroxide or potassium hydroxide. The third one is that is not enough. When you have soap, you have some nice perfume that comes out from there. The color, there are different things. So we'll now call them additives. After having the major, which is the fatty acid or the vegetable fat, and the second one, which is the strong inorganic alkali, or that is sodium hydroxide or potassium hydroxide. What now makes the soap look attractive? A very nice perfume. There is the additives. So additive is the third one. Additives are used to enhance the color, the texture, and the scent that comes out from the soap. So we call them additives. So the third one is additives. Then the fourth one is fragrances. Fragrances and perfume. Fragrances and perfume. Then the last one is the abrasives. Abrasives such as the talc, silica, marble pumice, to enhance the texture of the soap. There are some soap, when you touch them, they are rough. When you touch them, they are smooth. You touch them, they are different, just the texture as a result of these fragrances and perfumes. So these are the raw materials that are needed for the manufacture of soap. Then the fourth question is, 4A number 3. 4A number 3. 4A number 3. 4A number 3 is name the main byproduct obtained from the manufacture of soap. The main byproduct that are obtained from the manufacture of soap. What are the byproducts? From the equation, from the equation, you will see that the byproduct, which I said it there, was the alcohol, or what we call the glycerol. I said it was, we can name it using the IUPAC system of nomenclature as propan 1,2,3 triol. Propan 1,2,3 triol. That's what I said, that we can use that as the byproduct. This is it. When you do this, when you react this in having the soap, which is the soap now, that is the byproduct that is there. After reacting the triglyceride with strong alkali, you will have the soap, which is the fatty acid salt, and propan 1,2,3 triol. So the byproduct we have here is propan. The byproduct obtained from saponification is glycerol. Either you write it as glycerol, or you can put in the IUPAC name as propan 1,2,3 triol. That is the byproduct, the glycerol. Let's go to 4B. 4B. 4B is question 4B. Question 4B will have to do with 4B will have to do with some organic reactions. What type of reaction is represented by each of the following equations? The type of reaction that is represented by the following equations. You will have here, this is an alkane. An alkane reacting with chlorine. When you see an alkane reacting with chlorine, and in this case, one of the hydrogen has been substituted by one of the chlorine atom, and one of the hydrogen again with the chlorine atom form hydrogen chloride. What comes to your brain is what we call substitution reaction. That's halogenation of alkane. The substitution reaction between alkane, and this, for the purpose of revision, this reaction will only occur under an UV light. We will act as a source of the catalyst. The ultraviolet light, or what we call the sunlight, will act as a catalyst for this substitution reaction. So the type of reaction involved here is a substitution reaction. Substitution reaction. That is the type of reaction involved here. We call it substitution reaction. So it is substitution reaction, or chlorination of propane. That is substitution reaction. Then 2, the second reaction here for 2. Here you will have, this is a polymer. This is a polymer formed from a monomer. This N, this is an alkene, and which precisely we call it ethene. This is ethene molecule to N. There are N number of moles. That's how we write an equation for the polymerization of ethene. N number of moles will polymerize. This is like a monomer. N number of this monomer will polymerize, will undergo what we call addition reaction to form a polymer to a certain number we don't know. So in that case, we are saying that this is addition polymerization. This addition polymerization of ethene. Addition polymerization of ethene. That is 2. And number 3, we will have a molecule here, C16H34. In that case, H34, that is an alkane. It's an alkane. It breaks down to give an ethene. It breaks down to give an ethene plus another alkane. What do you say this type of molecule is? When a large molecule breaks down to give an alkene and an alkane, what do we call that type of reaction? We call that type of reaction cracking of alkane. So the reaction is cracking. The type of reaction is cracking of alkane. So you can even add there that it is thermal or catalytic, because there are two types of cracking. One will maybe by through a catalyst or by heating at high temperature. So we can say catalytic cracking or thermal cracking. This is the cracking of alkane. So the reaction is cracking. Number 4, you have an ethene molecule. This is an alkene, which is ethene, reacting with hydrogen to give an alkane. This type of reaction here, when addition of a hydrogen molecule to an ethene molecule, we call that hydrogenation. We call that hydrogenation. And for the purpose of revision, hydrogenation, the condition under which hydrogenation occurs is you may either use a platinum or a nickel catalyst at 200 degrees Celsius. But that is not needed. What is required is just name the type of reaction. So we call this hydrogenation reaction. Number 5. Here you will have ethanol and carboxylic ethanol and sulfuric acid. When ethanol reacts with sulfuric acid, we remove. There's what we call this reaction. In this reaction here with ethanol, if you see this reaction with ethanol here, we will call it a displacement, or a displacement type of reaction. C2H5 HSO4 plus a molecule of water. The OH has the hydrogen of one of the hydrogen has mixed with the hydrogen to form a molecule of water. So if you see an alcohol reacting with an acid to form a molecule of water, what do we call that? It is a neutralization reaction. This reaction is very, very confusing for some students. When you have an acid reacting with an alcohol to form a salt, this is a salt. This is a salt, and this is a molecule, and this is one molecule of water. So we call this a neutralization reaction. This is a neutralization reaction, forming a salt and a molecule of water. So you go back to the answer scheme, you will see that number 5, I just discovered that number 5 was not right. So what here we call this a neutralization reaction. An acid reacting with an alcohol to form a salt and a molecule of water. We call that a neutralization reaction. So number 5 is a neutralization reaction. So put in your mind that it is neutralization reaction. So it is neutralization reaction. Neutralization. Neutralization reaction. Now, let's go to the C part of it. 4C, 4C1, 4C1. An organic compound U produces effervescence when reacted with sodium metal. It produces effervescence when reacted with sodium metal, liberating gas V. Liberating gas V. U produces a sweet, fruity smelling liquid. U produces a fruity smelling liquid when warmed with colorless liquid W. Okay, U produces this one when warmed with this one in the presence of a catalyst. Remember, organic compounds that produce sweety, fruity smelling are esters. Okay, W react with sodium hydrogen trioxocarbonate. That is sodium hydrogen trioxocarbonate. That is sodium hydrogen carbonate solution to produce gas G. Question number 1. Write the functional group present in U and W. The functional group from all investigation, an organic compound U produces effervescence when reacted with sodium metal liberating gas V. What will react with a sodium metal to produce a gas V? You will see that when an alkanol or an alcohol reacts with a metal, an alkoxide is formed. When an alcohol reacts with a metal, an alkoxide is formed. And in the course of doing that, a hydrogen gas is liberated, is released. That is the cause we are saying that effervescence. So U is supposed to be an alcohol. And the gas V produced is supposed to be what? It's supposed to be hydrogen gas. So V, U is, in this case, U is, they are saying write the functional group present in U. It is supposed to be an alcohol. In that case, U has an OH. U has an OH group. Then they said U produces a sweet, fruity smelling liquid when warmed with colorless liquid W in the presence of a catalyst. So remember that when alcohol react with acid, they produce, in the presence of a strong catalyst such as concentrated sulfuric acid, an ester is being produced, and that ester produces a sweet, fruity smell. So in that case, W is supposed to be an acid. So the functional group for W is supposed to be COOH, a carboxylic acid group. Then 2, identify gas V and gas G. Okay, I said W is supposed to be a carboxylic acid. W reacts with sodium hydrogen trioxocarbonate 4 solution to produce G, gas G. Remember that when acid react with a carbonate, it is sodium hydrogen trioxo, that is sodium hydrogen carbonate. When an acid reacts with a carbonate, carbon dioxide is usually released. So G is supposed to be carbon dioxide. So identify gases V and G. V is supposed to be hydrogen. V is supposed to be hydrogen gas when acoside was being produced. And G is supposed to be carbon dioxide. Okay. This is it. So now, as I said, U has an OH group because only alcohol will react. Only alcohol can react with sodium to produce a sodium acoside and a hydrogen gas being released. Then secondly, I said the functional group for W is COOH. You can write it this way. Then the gas V is hydrogen gas and gas G is carbon dioxide. Now let's go to number 3. Name the type of reaction between U and sodium metal. The type of reaction between U and sodium metal, if you look at this reaction here, look at the reaction. The reaction between U and sodium metal, we have an alcohol here, I just represented by an alkyl group, which is arrow, plus this one. You will see that it is a displacement reaction. This is a displacement reaction in the formation of an acoside from alcohol and sodium metal. It's a displacement reaction. Okay, name the type of reaction between U and W. That is between the alcohol and the acid. I told you when an acid reacts with an alcohol, an ester is being formed. So this process of formation of an ester between acid and carboxylic acid and alcohol, a carboxylic acid and alcohol, we call that esterification. An ester is formed and a molecule of water that is being released. It's a condensation reaction. Esterification is a condensation reaction because water molecule is released. So the type of reaction is esterification. Now let's go to the other section of it. Name the catalyst used in the reaction between U and W. I told you that for an ester to be formed, there must be concentrated sulfuric acid as a catalyst. So the catalyst used in esterification is concentrated sulfuric acid. Let's go to question number 5. Question number 5. If the molar mass of W is 74 grams per mole, deduced the molecular formula, deduced the structural formula of the compound. This is calculation. How can we deduce this? The molecular formula of W is 74 grams per mole. Deduce the molecular formula, deduce the structural formula. We have been given the relative atomic mass of hydrogen to be 1, of carbon to be 12, of oxygen to be 16. This is how we can solve the problem. Okay, step number 1. This is 5. Step number 1, let W be equal to the carboxylic acid. Let W be equal to RCOOH. We don't know because this W is a carboxylic acid. It is an alkyl group attached to the acid functional group. But this is equal to 74. Because the question is saying, if the molecular mass of W is 74, and I said W is a carboxylic acid, the functional group in W is an acid group. So we don't know we don't know what type of acid will give us 74. We don't know the alkyl group. So now that is why I said in this calculation, step number 1, solve for R. Let W be equals to R COOH. Now let's sum up everything. W plus 12, which is carbon, then oxygen there are 2, 16 times 2 plus hydrogen 1 equals to 74. R plus 45 equals to 74. Our value for R is 29. Our value for R is 29. Now, we cannot just take 29 like that. But the general formula for acid is what? It is CnH2n plus 1 COOH. That is the general formula we give for acid. CnH2n plus 1 COOH. So step number 2, solve for n. Solve for the n. By solving for the number of n, we will not know the number of carbon atoms that are involved in this general formula. We have got for R. R is the total of the alkyl group, but we don't know the number of the carbon atom. So we need to solve for n, which is the carbon atom. CnH2n plus 1 COOH. So where n is greater than 2. Okay, solve for the value of n. Let R be equals to what? CnH2n plus 1. So now, that is the arrow, because the arrow he was here. Arrow is here. Arrow is we cannot include COOH there. So let arrow we want to solve for we are solving for the alkyl group. Solve for n to know the alkyl group. So let arrow be equal to CnH2n plus 1. In that case, since we said arrow is 29, this formula equals to 29. It will be equal to what? C14n. 14n equals to 20. 14n, that is Cn plus 2n plus 1. When we calculate the number of n, we will have 14n. Then 1 will come on this other side, it will be 20. 1 will come on this other side, it will be 29 plus 1. 29 minus 1, it will be 28. So 14n equals to 28. So n is 2. So the value of n is 2. Now, substituting in the carboxylic acid equation, a formula, that is step 3. Substituting n in the general formula for acid. Substituting n in the general formula for acid. So here it is 2. It is C2. 2 times 2 is 4. 4 plus 1 is 5. That is H5. Then the acid group is COOH. So this is the molecular formula for the acid. The acid is propanoic acid. C2H5COOH. The acid is propanoic acid. Now, they are telling us 5,2 give the structural formula for the acid. The structural formula for the acid is CH3, CH2, COOH. That is the structural formula. This is what we call the displayed. This is what we call the displayed formula. That is from the displayed formula we can have our structural formula. So our structural formula is CH3, CH2, COOH. That is the structural formula. Now, that's all about the question. That's all about the question. So the question is very, very technical. If you do, you have to go through it again if you want to understand how to solve it. D. Explain briefly why the reaction between magnesium and 1 mole per dm cube ethanoic acid would be slower than the reaction between magnesium and 1 mole per dm cube hydrochloric acid. Remember, these are two acids, hydrochloric acid and ethanoic acid. The other one is inorganic acid, and the other one is organic acid. So, what will make them to, the other one is a strong acid, and the other one is a weak acid. And what is the characteristic of strong acids? Strong acids, they decompose or they ionize completely in solution. They ionize completely in solution, releasing all their hydrogen ions. And that is what makes the reaction very fast. So the one in, we can now say that the reaction with hydrochloric acid is faster. The reaction with magnesium ribbon and hydrochloric acid is faster because hydrochloric acid is a stronger acid than ethanoic acid. That is, it ionizes completely in solution, releasing all its hydrogen ions, therefore speeding up the rate of the reaction. So that is what you can put there. You can put it there. Or you can put it in this way. Even though hydrochloric acid and ethanoic acid have the same concentration, hydrochloric acid is a stronger acid than ethanoic acid, and it ionizes in solution completely, releasing all its hydrogen ion, thus increasing the rate of reaction. Finish. You can attach the equations there. So it takes us, I think that is the last section of this question. So question number 3. We are on question number 3. We are going to be dealing with question number 3. We are going to be dealing with orbitals and bonding. So now, question number 3. What is the shape of A1? What is the shape of s orbital? 2. What is the shape of p orbital? An s orbital, as you know, an s orbital is spherical in shape. I said an s orbital is spherically symmetric and non-directional. It is spherical, or you can say spherically symmetric and non-directional. Or let me just draw it. Meanwhile, a p orbital, yeah, just 3 marks there. When you write it, you can draw the diagram so that the examiner will know precisely what you are saying. You write it. When you write it, I said the s orbital is spherically symmetric and non-directional. You draw the diagram. The p orbital is dumbbell shaped. It is dumbbell shaped, and you also draw the diagram. That's one and a half mark. So you have it there. Let me just show you how you can come about it. How you can do that. In this case, this is how you can do it. Very good. This is how you can draw for question number 3. You can put it in this way. I said the s orbital is spherically symmetric and non-directional. You can put it this way and draw it like this. This is x, y, and z. And this is the nucleus. That's the s orbital. Meanwhile, the p orbital, I said the p orbital is dumbbell shaped. It is dumbbell shaped. This is like the shape of the bell. And it has some other sub shape. We have the x, y, and the z. This one, x has a corresponding here. I mean, z has it here, and the other one here, and the y on this other side. And this is the nucleus. When you draw the shape of the p orbital like that, the examiner knows that you know what you are doing. Okay, let's go to the other section of the question. The other section of the question has to do with bonding. It has to do with bonding, which is bonding. That is, you are given which ion has the following composition. Which ion has the following composition? Ion. That is the second part of it that we did not mention. Which ion has the following composition? 0 electrons. It has 0 electrons. It has 2 protons. And it has 2 neutrons. 0 electrons, 2 protons, and 2 neutrons. Remember, I told you that protons are the same. Protons are the same as protons are equal to the number of the proton number is equal to the electron number. But now it is an ion, implying that the electrons have all been lost. So if 2 electrons have all been lost, and the proton number is 2, then it is a helium ion. The only proton that has 2, the only element that has 2 protons is helium. And the number of protons are equal to the number of electrons. And if all the electrons have been lost, then the 0 electron, it is helium ion. And this is how you can write the helium ion. This is how you can write it there. A helium ion can be written in this way. A helium ion can be written in this way. This is how you can write it. This is how you can write it. This is a helium ion. All the 2 electrons have been lost. We only have 2 protons left. We only have the atomic number. So the number is a helium ion. Okay, let's go back again. Let's go back again. Now, we are going to question which section of it. The table. The following table shows a melting point and boiling point of oxides of the element X, Y, and Z. We have the oxide, we have the melting point, and we have the boiling point. What we now do here is that, what we are going to do here, based on the oxide, you will see that oxide here, there is X2O, there is X2O, there is Z2O. The boiling point, look at the boiling point. From the boiling point, we will determine the type of bonds that are here. The melting point here is 1,403. And the melting point is 273. And this is the lowest. Again, the boiling point is the highest here. And the boiling point is decreasing. Okay. Remember, this one has strong bonds. This one is next to it, and this is the weakest bond. The force of attraction in X2O is strongest. The force here is just stronger, and this one is just strong or weak. So the question says, what type of bond binds X, Y, and Z respectively to oxygen in their oxides? The type of bond that is binding. What type of bond binds X, Y, and Z respectively to the oxide in their to the oxygen in their oxide? So the type of bonds here will be what? Type of bond bind. What type of bond binds X? Binds Y and binds Z. So it should be noted that the type of bond that will bind X to its oxide is what? Is ionic bond. Because X to its oxide, the type of bond is ionic bond, because the force of attraction between them should be electrostatic force of attraction, which is that will need high energy to overcome it. Then for Y2O, the type of bond, the bonding in Y2O, the type of bond there is a covalent bond. And above all, the type of bond that will bind Z2O should be weak, simple covalent bond. It is simple covalent bond. Okay, so now I said to explain briefly how the bond in ZO is formed. ZO, as I said, this ZO is a weak bond. It is a weak bond. So this is how the bond is being formed. Explain how the bond in this is being formed. Okay, let me just show you how that bond is being formed. Let me just show you how that bond is being formed. Here, as I said, bonding between X and O in X2O is ionic bond, like the one in sodium oxide. Bonding between YO in this is a covalent bond, like the one in this. Then bonding between Z and O, like this, is because the covalent bond in water vapor is stronger. Then the type of bond between Z and O in Z2O is a covalent bond, like the one in chlorine 1 oxide. So they are telling us how this is being formed. Remember, in Z2O, I said in Z2O, bonding here is simple covalent. Is simple covalent in Z2O. Bonding here is simple covalent bond formed by two atoms of Z contributing electron each for sharing with oxygen. Let's take Z to be a halogen. I said like the one in chlorine 1 oxide. So this is how it can be formed. This is Z and this is Z and this is this. The same way chlorine 1 oxide. If we take Z to be a halogen like chlorine, this is the type of bond that will be formed there. So this is the type of bond that is formed between Z and oxygen. That is how you can get it. Then let's go to 3. The third part of our question is the third part of our question is okay, what type of forces holding the molecules of what type of forces hold the molecules of Y2O to Z2O respectively? I told you that the forces holding forces holding for Y2O, the forces holding molecules of Y2O are intermolecular forces. That is why it has a very weak forces holding. Forces Y2O. This is Y2O. The forces holding this one are what we call intermolecular hydrogen bonds. The forces holding this thing here are what we call intermolecular hydrogen bonds. All of them are covalent bonds. But the covalent bond here are intermolecular hydrogen bonds, and the one here are van der Waals forces. So the forces holding this one are intermolecular hydrogen bond, as it is the case with water vapor. Then again, the forces holding molecules in this one, in Z2O, to give a melting point of just 49 or a boiling point of 49, are what we call the van der Waals forces. Forces holding the molecules in this are weak van der Waals forces with dipole attraction. Weak van der Waals forces with dipole attraction. You can see what I am talking about. This is what I'm talking about. The forces holding this one Forces holding in Y2. I said the forces holding this one is what are intermolecular hydrogen bonds, as it is the case in water vapor. These are intermolecular hydrogen bonds holding them. Then the forces holding Z2O, forces holding the molecules of Z2O together are van der Waals forces. They are weak van der Waals forces with dipole-dipole attraction, as it is the case with chlorine 1 oxide that I showed you. Chlorine 1 oxide. Then the C part, the 3C. Let's go to 3C. 3C is 3C is the following equation illustrate homogeneous equilibrium established. Once more, the following equation illustrates homogeneous equilibrium established when hydrogen and carbon react, and carbon dioxide or carbon 4 oxide react. This is the equilibrium. Why is this reaction regarded as a homogeneous equilibrium? Why is this reaction regarded as a homogeneous? Is regarded as homogeneous. This reaction here. Why is it regarded as homogeneous? It is regarded as homogeneous because both reactants and products, both the reactant and the product species are in the same phase. The reactants are gases and the products are gases. That's why I say it is regarded as homogeneous because both reactants and product species are in the same phase, that is gaseous state. 2. Explain briefly the effect of an increase in pressure on 1. Equilibrium position. Equilibrium position here, the effect of an increase in pressure. Now, they are all gases, they are all gaseous reaction. They are all gaseous reaction. So, what will be the effect of an increase in pressure on the equilibrium? There will be nothing, no effect. The effect, if the pressure is increased, there will be no effect on the position of equilibrium. Why? That is the reason. First thing is no effect. The reason is increasing the pressure will have no effect on the equilibrium position because the number of gaseous molecules on both sides are equal. The equilibrium cannot shift to the right or to the left because excuse me, the equilibrium cannot shift to the left or to the right because the number of the gaseous molecules on both sides are equal. That's just all. Then the rate of reaction. Briefly, effect of an increase in pressure on the rate of reaction. Yes. Increasing, that is 2. Increasing increasing the pressure will increase the rate of reaction. Let me explain. Increase in pressure will increase the frequency of successful collision. That will increase the frequency of successful collision between particles and the walls of the container, resulting in an increase in the rate of reaction. So that is just what you can write. So when you look at it for gaseous reaction, when it comes to pressure, you have to check the number of molecules on the left-hand side and on the right-hand side. Just as I said, I have said C1, I once more, both reactants and product species are in the same phase. That is why it is homogeneous. 2, equilibrium position, no effect, because increasing the pressure will have no effect on the equilibrium position because the number of gaseous molecules on both sides are equal. 3, on the rate of reaction, the rate of reaction increases. when the pressure is increased. The reason is this: increase in pressure will increase the frequency of successful collision between particles under the walls of the container, resulting in increase in the rate of reaction. So the other one is the other section is the other section is that is 3. The third part of it is state 3 features of an equilibrium reaction. 3 features of an equilibrium reaction. For an equilibrium reaction, when we say something is in an equilibrium state, what are these characteristics of a reaction that is in an equilibrium state? The 3 features are as follows. 1. The rate of forward and the reverse reaction are equal. 2. All reactants and the products are present at equilibrium. 3. The position of equilibrium is not affected by a catalyst. That's what you are supposed to know when it comes to that. That's what you are supposed to know when it comes to that. 3 features of an equilibrium reaction. The 3 features of an equilibrium reaction. I said the 3 features of an equilibrium reaction. I said in an equilibrium, in a chemical equilibrium, the rate of forward and reverse reaction are equal. All reactants and products are present at equilibrium. The position of equilibrium is not affected by a catalyst. These are the features of an equilibrium reaction. Now we are going to the last section of that question. The last section of that question is it has to do with calculations. D. The D part is on calculations. So they are saying that a compound Q contains 29.1% sodium, 40.5% sulfur, and 30.4% oxygen. Determine 1. The empirical formula. 2. The molecular formula of Q if its molecular mass if its relative molecular mass is 158. Oxygen, relative atomic mass of oxygen 16, of sodium 23, and of sulfur 32. Now you need to write all these down. Write all these down and write their different percentages and the relative atomic masses and look for their moles. Let me show you how it is done. This is how this is done. In this situation, for 3D1, you have to write sodium, sulfur, and oxygen. Then, secondly, you will have to write their percentages. Thirdly, you will have to write their relative atomic masses. And fourthly, the number of moles. How do we get their number of moles? By dividing their percentages by their relative atomic masses. When we divide 29.1 divided by 23, we will have this. 40.5 divided by 32, we will have 1.266. And 30.4 divided by 16, we will have 1.9. Step number 2, in order to have the simplest ratio, in order to have the simplest ratio, we have to divide by the smallest value here. And the smallest value here is 1.265. So we have to divide all by 1.265. And when we divide all by 1.265, the simplest ratio we are going to have here will be 1, 1, 2. What the one was 1.5, approximately is 2. It is 1, 1, 2. So our empirical formula will be NaSO2. Then the molecular formula. In order to calculate the molecular formula, we were given the relative molecular mass. The relative molecular mass of the compound to be 158. So the relative formula, the molecular mass of Q, the molecular formula of Q, in order to have it, we have to make use of the relative molecular mass that was given, which is 158. So what we are going to do now is we will take the empirical formula, which is this one, times a certain number n, will give altogether 158. So if we multiply everything by n, we will have 87n, which is equal to 158. Therefore, our value for n is 158 divided by 87. N will be 2. Now, substituting the value of n in this empirical formula, we will have, if we now put 2 here as n, so it will be Na2, S2, and S2, and O4. So Na2, S2, O4 will be our molecular formula. That is it. That is how you can calculate that. So thank you very much, learners. I think we are done with this question. We are still going to we'll be going to question number 4 and number 5. So we are done with question number 4 and question number 3. So we are left with question number 5 and question number 6. So thank you for listening. Once more, for those of you who haven't subscribed to our channel, please take some time and subscribe to the channel so that all other papers that we are going to be solving will come directly to you. Before we go, my special gratitude goes to myschoolgist.com, who made available to us the question paper. Thank you very much.